Okay, this is just a bit more of a difficult combination chain in a product rule. So here, clearly y equals u times v. Let's not worry too much about the setting out, but you will in your test, won't you? U equals x squared, so u dash equals 2x. V is root x cubed plus 1. Let's not go straight to our answer here. This is where we're going to be thinking, that's a chain rule, so let's set v equal to w to the half. Again, I'm not usually a chain rule, I set that equal to u, but I've already used a u, so let's go w. So, and w equals x cubed plus 1 dv dw. Now I'm going to go the long way. Is we're going to bring the half down, and a half minus 1 is minus a half. So that's 1 on 2 w to the half, and I can write that as 1 on 2 root w. So that's just showing you how I'm going to get to 1 on 2 root w. And here, dw dx is 3x squared. Okay. So v dash, which is what I want up here, is dv dw dw dx. dv dw is 1 on 2 root w times 3x squared. So 3x squared on 2 root x cubed plus 1. So again, that's v dash, and that is the calculations to get my answer up here. 3x squared on 2 root x cubed plus 1. Let's tidy this up a little bit, because we're going to be needing some room here, aren't we? So we're set up now for our product rule. So y dash equals v u dash plus u v dash, and we've got all of our requirements up here, so it's straight substitution. V u dash plus u v dash okay, looks nice and easy, doesn't it? Let's just tidy that up a little bit. These two will go together, so I've got 3x to the 4 Now you'll notice here, I haven't really written that out to say that, well, that's the end of it, have I? You'll see I've left a big gap in here. So whenever we're giving our answer for y dash or the gradient function, we really want to be in factor form, or at least here we're thinking, I want to add these things together, but this is a fraction. So I'm adding fractions. To add fractions, I need a common denominator, and this is it here. So I want to multiply both sides of this fraction here, 2 on 2, like that. And that's a fraction on 1. So you can see here that I've got this common denominator now. So my next line is all over x cubed plus 1. That can just go out there, that's nice and easy. Now, this is 2x multiplied by the 2 roots, and we've got another 2 in there. So it's 2x times 2 is 4x, and multiplying two square roots together undoes each other, so instead of being a square root, I'm just going to put a bracket, just like that. So the square roots have undone themselves. I'll just run out a bit of a room. So let's work up the page now. Okay, so I want to get rid of these brackets. So that's going to be 4x to the 4 plus 4x plus 3x to the 4 all over the 1 square root. 4x to the 4 plus 3x to the 4 is 7x to the 4 plus 4x on 2 x cubed plus 1. The only other thing you could do is drag that x out. See, we've got an x to the 4 here and an x there. So I guess I could put that in a bracket and put an x out the front. Therefore, the gradient function is now in a fantastic looking factor form, and we will use that factor form a lot when we get to optimization. Okay, you can see how tricky these get, so make sure you do a lot of practice.